touching me.
All right, guys. We're going to go on and get started. So, fundamental theorem of algebra. We have that nice chart, but we're going to go on and look at the fundamental theorem of algebra. Fundamental theorem of algebra states that if f of x is a polynomial of degree n where n is greater than 0, we're just saying that f of x is not equal to a number. That's all that means. So f of x cannot equal 4 for this theorem to work. If we actually have a polynomial function of where n is greater than 0, then the equation has at least one solution in the set of complex numbers. Well, up to this point, you could say that's probably not true because we've had pretty much every equation, the solutions that we had for 4 or 5 did not contain a complex number, did not contain a value with I, yes? X equals 3, is that a complex number? It is now. I can add 0i. Like, if it doesn't have I in any of the solutions, we can really say that one has 0i, so it is a solution to complex blank. Doesn't tell us a whole lot. The corollary is more important. Corollary says if f of x is a polynomial of degree n where n is greater than 0, then the equation has exactly n solution provided each repeated solution twice is counted as 2 solutions. And each repeated solution 3 times is counted as 3, so on and so forth. So that means the degree is equal to the number of solutions. So, if we look at this here, x cubed plus 3x squared plus 16x plus 48, how many solutions does it have? What's its degree? So how many solutions should it have? 3. Because the number of solution is equal to the degree. Now, it didn't ask us to find the solution. It just said how many does it have. Negative 3, 4i, negative 4i. That's it. How many zeros should this function have? What's the degree? So it should have. And if we found them, we didn't have to. It'd be negative 2, negative 2, negative 2, and 0. Questions on this here? How many solutions should this one have? 4, because the degree is yeah, 3. Because the degree is 3. Questions on these so far? X to the 5th plus x cubed minus 2x squared minus 12x minus 8. How many solutions should this one have? 5. However, it's not asking us to just state how many zeros it has. It actually wants us to find. So the first thing I would do in finding the zeros is going to graph. First thing I would do is graph it. So we're going to type it in as x to the 5th plus x cubed minus 2x squared minus 12x minus 8. We're going to type it in and graph. And when we graph it, we really want to find n minus 2 solutions where n is the degree. Since it is a degree 5, we want to find at least 3. Now, we do see that it crosses the x-axis at one spot and it touches the x-axis at another. So with polynomial function, and we've kind of talked about this already, when it crosses the x-axis, we say that it has an odd multiplicity. There's an odd number of zeros at that location. So at 2, the number of zeros at that could be 1, 3, 5, 7, 9, an odd amount. However, we cannot say it's going to be 7, or really 5 zeros at that spot. Because what was the degree? 5. So how many solutions should we have? So is there any way that I could have 7 solutions of 2? No, that's too many. I also can't have 5 solutions of 2 because we know what? -1 has to be 1. So there's no way I can have 5 solutions of 2 because one of them's already taken. Now at -1, we see that it touches the x-axis but does not cross it. Anytime it touches the x-axis but does not cross it, it has an even multiplicity. There's an even number of zeros at that spot. So for us here, we're hoping it means that -1 shows up twice. Now we can look at the table and it does tell us that -1 is 0, and at 2 it is 0. So we know for sure 2 and -1. Now we do need to set the synthetic division up. Across the top, we're going to put our coefficients. We'll put the numbers in front of our variables. Now we will have 1 for x to the 5th. But since we do not have an x to the 4th term, we're going to have to fill it in as 0. Our x to the 3rd term would be 1. X squared is -2. X is -12. And our constant term is -8. We bring down the first term. Do we want to use or to try 2 or -1 first? -1. So we're going to multiply. -1 times 1 is -1. At this point here, we're going to add straight down. So 0 plus -1 is -1. -1 times -1 is 1. 1 plus 1 is 2. -1 times 2 is -2. -2 plus -2 is -4. -1 times -4 is almost just 4. -12 plus 4 is -8. And -1 times -8 is just 8. Telling us that -8 plus 8 is 0.
Oh, stop.
All right, guys. Do we want to use -1 or 2 next? 2. So we're going to use 2 next. We're going to do this again. 2 times 1 is 2. All right, guys, let's keep volume over here down. Yeah, then let's keep the volume down. -1 plus 2 is 1. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. -4 plus 8, almost 4, since the 8's bigger. 2 times 4 is 8, and -8 plus 8 is 0. Now we said there's a chance that which one worked twice? Was it 2 or -1? You try 2. 2 times 1 is 2. 1 plus 2 is 2 times 3 is, I would stop at this point here, because what's happening to our numbers? They're getting bigger, yes? So 6 plus 4 is going to give us 10. 10 times 2 is 20. 20 plus 4 is 24. We don't get 0. And the reason I'm saying they're getting bigger is that's fine, but because we do not have a negative anywhere that's going to cause it to get smaller again, it's not going to work a second time. So our only other option is -1. -1 times 1 is -1. 1 plus -1 is 0. -1 times 0, 0. 4 plus 0 is 4. -1 times 4 is, and 4 plus -4 is 0. At this point here, we do have it down to a quadratic, so we can go on and plug our variables back in. Telling us that the final equation we need to solve is x squared plus 4. That last number is our remainder. Our 4 is our term without x. 0 is the term with x, and 1 is our term with x squared. So our final equation is x squared plus 4 equals 0. Now, because there is no middle term, there is no term with x, we can subtract 4 from both sides. Because we're doing our square root method, we just need to get x squared by itself. Telling us that x squared is equal to negative 4. Since the variable is indeed, not the variable, but our square term is by itself, we can take the square to both sides. Our square root of x squared is x. Whenever we take square to both sides, we have to put the plus or minus. Now when you take square to negative 4, it is indeed 2i. The negative would come out as I, leaving us with just the square root of 4 to simplify, and the square root of 4 is indeed. Questions on this here? So that tells us our solutions for this here are 2, negative 1, 2i, and negative 2i. Questions on anything we've done so far? Be ready for the next one. X cubed plus 7x squared plus 16x plus 12. So we're going to graph this here. And we get this. Now, because the degree is 3, we know we should have 3 solutions, yes? And as I've been saying for pretty much most of this week, we want to find n minus 2 solutions where n is the degree. Degree is 3, so we want, at worst, find 1. Better case is we find 2. Best case is that we find 3, yes? So we see those 2 spots, and if we look at it, it's telling us x is negative 3 and negative 3 and negative 2. Okay. Now, as we look at this here, and it probably looks the same way on your calculator, it looks like it could be touching that x-axis and going back up. It may cross it, it may not. It's a little fuzzy just on how it looks. Because on some of the ones we had earlier, especially the last one, it was kind of nice and easy to tell that it hit at negative 1 and went back down. Here it looks like it might cross. Would we agree with that? Let's throw some of our knowledge that we do have at this, because I didn't actually talk about this 4th hour. We know that if it crosses, it could be irrational. Our irrational numbers do cross, we have our square roots. But according to the irrational conjugate theory, it states that if a plus the square root of b is a solution, a minus the square root of b is a solution, yes? If we have one, we have to have the other. How many solutions do we have remaining? So is there any way that other solution is irrational, has a square root? No, because if it is, I have to have how many more? 2, yes? So could that other solution be imaginary? No, we haven't covered, well, we've talked about it before. If a plus the bi is a solution, a minus the bi is a solution. If we have one, we have to have the other. Imaginary solutions always come in pairs, so there's no way that's going to be imaginary. So imaginary and irrational solutions are gone, because we only have one left, yes? Wait a minute. Whenever we looked at these here, and we solved these, if it was, say, fractional, because that's the only thing we have left that could be between negative 1 and, or negative 2 and negative 1, that leading coefficient was something other than 1. Some way for us to get a fraction, yes? What's the leading coefficient? So is there a good likelihood that's going to be fractional? No, so the only really option we have left is that this has to be negative 2. But we can make sure With synthetic division, simplify it all the way down and see what we get. Now, it really doesn't matter which one we use first. We can use -3 or -2. Did we use -3 or -2 for fourth hour? Yes. We'll do -2 this time. Because at least you'll see this, and because I was trying to explain this, that it doesn't matter, but it does change how it looks. Because we'll still get a remainder of 0. -2 times 1 is -2. 7 plus -2 is 5. -2 times 5 is -10. 16 plus -10 is 6. -2 times 6 is 12, and 12 plus -12 is 0. So it did change the numbers, but it doesn't change what the solution is. And at this point here, we can use -3 and do it again. Now, -3 times 1 is -3. 5 plus -3 is 2. -3 times 2 is -6. And 6 plus -6 is
0.
So even though the numbers changed, we still got to the same location. And at this point here, we can fill the variables back in and solve our final statement, which is x plus 2 equals 0. X is equal to -2, confirming that it did have a repeated 0 of -2. Questions on this here? We're going to do one more solving, and then we're going to start and hopefully finish one of the Descartes' rule of signs. We'll finish it tomorrow. But here, x to the 5th minus 3x to the 4th plus 5x cubed minus x squared minus 6x plus 4. How many solutions should we have? 5. How many are we looking for? 3. Because if we can get 3, we can get it down to a quadratic. If we can get 4, we can get it down to a linear. And if we get 5, we're done. We don't have to look for any more. It has all of them listed. And it'd be helpful if I'm actually typing the right problem in. We get this here. So we do see that it crosses at -1, and it looks like it touches the x-axis and goes back up at 1. So for us here, we can say x is -1, and we are hoping that 1 shows up twice, because it touches that x-axis and goes back up. 1 for x to the 5th, -3 for x to the 4th, 5 for x cubed, -1 for x squared, -6, and 4. Which solution do we want to try first? 1. 1 times 1 is? -3 plus 1 is?
4.
Almost.
Yeah.
-2. 1 times -2. -2. 5 plus -2. 5 minus 2. 3. 1 times 3. -1 plus 3. Almost. 2. 1 times 2. 2. -6 plus 2 is -4. 1 times -4 is -4. And 4 plus -4 is 0. Now, because it hit the x-axis at 1 and went back up, we're hoping that it works a second time. So let's go and do it a second time. 1 times 1 is 1. Negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. 3 plus negative 1 is 2. 1 times 2 is 2. 2 plus 2 is 4. 4 times 1 is 4. And negative 4 plus 4 is 0. Now the other solution that we had was negative 1. Now we're going to have some sign changes happening here. Negative 1 times 1 is negative 1 plus negative 1 is negative 2. Negative 1 times negative 2 is positive 2. 2 plus 2 is 4. 4 times negative 1 is negative 4, and 4 plus negative 4 is 0. Well, we don't have any more solutions between 1 and negative 1. Now, if negative 1, because it did cross at negative 1, did show up another time, because it does have an odd multiplicity, it can't just show up once. It's got to show up 2 more times to give us a total of 3. But according to this here, if it did show up 2 more times, it would mean the solutions for this are rational, which means we could factor it, which means 2 of the factors we need to come out of 4 have to be 1 and 1. That's not going to happen. And the same is true for positive 1. For it to be a solution, has to be rational, which means I would have to get 1 and 1. It's just not going to work. Not with this here. So we have to solve this here. Now, it is possible to do this by completing the square. I think quadratic formula is a little bit faster than completing the square. I default to this here. Now, our a value in this case is going to be the number in front of x squared. Now, because there's not a number specifically written in front of x squared, it's understood to be 1. So we can put 1 and 1. B is, so we'll put it in its 2 spots. And C is 4. So we have negative negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 4 all over 2 times 1. Now, negative negative 2 is going to become positive 2. And the denominator 2 times 1 is 2. Now, inside the square root, it's going to be nice to just type that whole thing in, let it simplify it for us. So, negative 2 squared minus 4 times 1 times 4 is negative 12. Now, we do need to simplify the square root of negative 12. So we will have I. That negative is going to come out as I. Yeah, or no, come on in here and take a seat. Or just hang out in here for the last 16 minutes. Now at this point here, we're left with I square roots of 12. So really, by taking that negative out as I, we can actually let the 30xs do this. And the square root of 12 is 2 square roots of 3, telling us that the square root of negative 12 is 2I square roots of 3. Now we can say that this is the final answer, that we're done at this point, as long as the two numbers on top, our two main numbers, 2 and 2I, do not have a common factor with the denominator of 2. Well, unfortunately, 2I, 2, and 2 all have a common factor of 2. So we're going to divide it out. Now, when I do these simplifying, I do look at the denominator first, because if I divide that 2 out of the denominator, it becomes 1. So there is a denominator, it's just 1, so we're not going to really write it as 1. The first 2 is also going to simplify to 1. Our 2I squared of 3, if we divide that 2 by 2, we're left with just I squared of 3. So we can say that this is 1 plus or minus I square roots of 3. Questions on this here? So our final two answers are 1 plus or minus I square roots of 3, telling us that these are the final answers. These are the solutions for this here. Questions on this so far? We feel pretty good with solving at this point. Pretty much most of the solving is what? Graph it, and then we're going to go from there. Complex conjugate theorems. If A plus BI is a solution, then A minus BI is a solution. If we have one, we have to have the other. Now here it told us 2 is a solution, 2 is a 0, and 3 plus I is a solution. Well, if 3 plus I is a solution, then what? 3 minus I has to be a solution. If we have 1, then we have to have the, well, then we would set these x equal to each one of these solutions, then we'd get them equal to 0, multiply them together, do that whole process, but we're going to skip that. It's not that I don't find it useful or necessary, it's more work than it is anything else. But the last thing we're going to look at is Descartes' rule of signs. Descartes' rule of signs states that if we take this polynomial f of x with real coefficients, so the numbers in front of the variables are real numbers, and we count the number of sign changes in f of x, it will tell us the possible number of positive real zeros or an amount even less than that. So whatever the number of sign changes is, we have that amount or 2 less than it, 4 less than it. We just keep subtracting 2. So if we counted the number of sign changes and it was 6, well, it says we can have 6, 4, 2, or 0 positive. Then we would do almost the same thing for the negatives, except we're looking at f of negative x, not f of x. So let's look at this first one here. Now, to find the possible number of positive zeros, we take the function f of x and we count the number of sign changes from term to term. So if I look at this here, from x to the 6th to x to the 5th, does the sign change? Because x to the 6th is what? Positive. X to the 5th is negative. Did the sign change? Yeah, so that's one sign change. How about x to the 5th to x to the 4th? Yeah, because it's going from negative to positive. So it's 2. X to the 4th to x cubed? Yeah, because we went from positive to negative, yes? X to the 3rd to x squared? No, we went from negative to, how about x squared to x? No. So the number of positive zeros, the most positive zeros we can have is 3. So that means if I find and I graph and find 2 positive zeros, there has to be a third somewhere, or an even number less than it. So I can subtract 2 from 3, because that's the smallest even number we have, and get 1. If I subtract 2 from 1, we get Negative 1, yes? Can we have a negative number of solutions? No, because it's a group of objects. We can't have a negative amount. So the most positives we can have is 3 or 1. Now to find the number of negative solutions, we're going to do almost the exact same thing, but with f of negative x instead of f of x. Now for this here, we're going to replace every x in f of x with negative x. So we're going to replace every x in f of x with negative x. So we have negative x to the 6th minus 2 times negative x to the 5th plus 3 times negative x to the 4th minus 10 times negative x cubed minus 6 times negative x squared minus 8 times negative x minus 8. Now once we simplify each one of these here, then we can count the number of sign changes, and that tells us how many negative zeros we can have. Well, before we start delving too far into this, I'm just going to look at that. So don't have to write this down. One, two, three, four, five, 6. We have a negative x to the 6 is just saying we're taking negative x and multiplying it by itself 6 times, yes? Let's ignore the negative for now. Here I have x times x times x times x times x times x. We're still multiplying x by itself how many times? So is it still going to be x to the 6? Well, yes, because it's still saying we're multiplying it by itself 6 times. So that's not changing. What's really we're looking at is the negatives. And that's the big thing with this here is figuring out those signs. So we're really more focused on what's going to happen to that negative. What's a negative times a negative? Positive. If we multiplied it by another negative, it becomes, well, now we have another one. But this here is going to become positive. 5 times 6 times is. So each time we multiplied this negative by itself an even number of times, it became what? Positive, yes? And each time we multiplied it by itself an odd number of times, it became what? Negative, yes? Okay. So if we look at the first one, x to the 6th, negative x to the 6th, well, we know it's just going to be x to the 6th. We already did that. We kind of showed that there, yes? Let's look at the next one, negative 2 times negative x to the 5th. So we have the negative 2. Now the x to the 5th is still going to be x to the 5th. But that negative, when we multiply negative by itself an odd number of times, it's going to stay negative. We're still going to have that negative, yes? But that means I have this negative x times negative 2. Well, that negative and negative would make a positive, yes? So we're really saying that we have 2x to the 5th. Well, what happened when we had that odd exponent? It changed the sign from negative to, or it could change it from positive to. So that exponent, if that exponent, especially, now this is mainly working if it's just negative x. If it's negative 2x to the 5th, negative 2 inside, we have to actually figure out what 2 to the 5th is. But for the signs, if that exponent's even, that negative is going to come out as positive. It's not going to change that sign. It's still going to be positive 3, x to the 4th. Our next one, we are still going to have 10x cubed because we don't have a number inside with that x besides negative 1. But because that exponent's odd, that sign in front of 10 is going to have to change from negative to positive. What's going to happen with the 6x squared? It was negative. Is the exponent even or odd? Even. If the exponent's even, it's going to stay the Same. If the exponent's odd, we change the sign. If the exponent's even, it stays the same. Now the next one, negative 8 times negative x. Well, the exponent is technically 1, which is odd, so the sign would change. But there is no exponent, so we could just what? Multiply. What's negative 8 times negative x?
8.
Is negative and negative make positive, so it gives us 8x. If the exponent's even, the sign stays the same. If the exponent's odd, change it. And now that we have that done, we're going to count the sign changes. X to the 6th to x to the 5th. Does the sign change? X to the 5th to x to the 4th. X to the 4th to x cubed. No. X cubed to x squared. Yes. X squared to x. 2. X to our constant. 3. So our negatives, the most we could have is 3, or an even number less than it, 1. Questions on this here? So we feel comfortable finding the number of positives and the number of negatives, yes? We're ready to actually write the answer out. Because the answer for this, these here, is going to come in the form of a table. So the number of solution types that we can have positive, we can have negatives, and we can have complex. Because graphically, complex solutions don't cross the x-axis. Now, the number of positives, the most positive numbers we can have is what? 3. How many? What was the most number of negatives we can have? 3. So if I have 3 positive solutions and I have 3 negative solutions, how many total solutions do we have? What's the degree? 6, isn't it? So how many total solutions do we have? 6. So if we have 3 positive and 3 negative, do we have all of our solutions? Yeah. So the number of complex that we could have is what? Because we have them all, don't we? If we have 3 positives and 3 negatives, there should not be any complex because they're all accounted for. Now, the way that I approach this from here, because we said that it could be that number or an even amount less. I start with the negatives and keep subtracting 2 till I can't anymore. So we can take a group of 2 negatives away. And I keep the positives the same until I can't reduce the negatives anymore. So I can take 2 groups of negatives away, saying that I have 3 positives and 1 negative, which gives us a total of how many solutions? 4, yes? How many solutions should we have? What's the degree? 6, so we should have 6, yes? How many am I missing? 2. So that means I would have 2 complex. If I had 3 positives and 1 negative, the others have to be complex. Can I take another group of 2 away from the negatives? No. And whenever I get to the point where I can't take any of the negatives away again, I reset it back to the maximum amount of negatives I can have, and take 2 away from the positives, and repeat this process. Because if I have 1 positive and 3 negative, we have to have 2 complex. Can we take 2 more away from our negatives? Well, yes. Because we could have 1 positive and 1 negative, which is a total of 2, which means I'm missing 4. Because again, then we would try to take 2 away from the negatives. Can I take 2 away from our 1 and still have a positive number? No. That'd be negative 1, yes? Then I'd look at the positive. Can I take 2 away from the positive 1? I can't do it in either case. We are done. So that is the answer. We're going to do at least 1 or 2 more of these tomorrow, and then we are done.